So very good afternoon to you all. So till now we have studied about raster data. So we learned how to read, how do we read, write, and do some elementary processing on the raster data. So from today onwards, we will start with vector data. So anyway, I think in the starting first lecture, you have been introduced to the vector data. Just for the sake of completion, I will just briefly summarize the what is vector data. So vector data represents object on the Earth's surface using their longitude and latitude. Plus, it may be a combination of pair of coordinates. So any object which we can represent on the Earth's surface either like maybe either as a point using their just latitude or longitude or just a combination of latitude and longitudes. So there may be line, polyline, polygon, multi-polygon, etc. So raster data, any data which is continuous in nature, so that we represent as using raster data, and the data which has discrete or clear-cut boundaries, so that data can be represented as vector data. So like suppose if you want to display the temperature, so temperature actually will be continuous data, so that will be represented as raster. But like suppose if you want to show the boundaries of a country or state or a city, so those boundaries has these are clear cut boundaries, so that can be like shape of or borders of any city or country, so that can be represented as a clear cut a vector data. So data that is definite boundaries, clear cut boundaries, so that can be represented as vector data. So vector data can be either like you can just represent it using a point like the two pair of coordinates longitude and longitude, so that will be a point, or it can be a combination of those pairs of latitude and longitudes that are called, that can be line, polyline, or polygon, etc. So this way we can represent vector data. So what is now vector data has line, point, line, and polygon. So point data, what is point data? So any a pair of coordinates using a pair of coordinates longitude and latitude that represent the location of points on Earth's surface. So that is point data. So maybe the example of location of some house, location of some landmark, like when city also you are looking at very large scale, even city can be represented as a point data. So point data that has latitude and longitude. Like here you can see that we are showing these multiple points. So these points actually depends on, so some even at the large scale the city itself can be represented as a point, or this can be a location of a house, location of a letter box, etc. So any point, so point means pair of latitude and longitude. So like these are 4 points. Then second, how do we represent vector data is using lines. Line is a series of points that represent a line. So line can be straight or curved line or straight or otherwise. So a series of points. So point was a single point and a series of points is a line. So like center of road we can represent using lines, or some river and etc. So here you can see these are all the points. So the pair or combination of these points, a series of these points is called a line. So like you want to represent a road or a channel of a river, so those things can be represented as lines in the form of vector data. So next is polygon, a series of points or vertices that define the outer edge of a region. So finally actually it should be a closed region. So from wherever you start it should close there. So that is called a polygon. So for example, outline of cities, like the boundary of cities if you want to represent, or continents, countries, etc. So any series of points in a closed, that should be closed in a closed loop. So that is called a polygon. So that can be like suppose if you want to show the boundaries of a country, city, or etc. So anything that can be represented using polygons. So these actually images has been taken from this. So Google Earth Engine and GeoPandas. So like here you can see that this is a map of Uttarakhand. So entire Uttarakhand is shown as different combination of multi different polygons. So every district or block has the boundaries of block has been shown here clearly. So this way we can represent the vector data. So vector data actually easier to handle compared to the raster data. So now for reading and writing vector data, we will use a library called GeoPandas. So it will just before GeoPandas, I will just give you briefly a introduction to another library called Pandas. Actually, GeoPandas is very much similar to Pandas. It's the only thing that it has support for geometries. So if you just know the basics of Pandas, then it will be quite easy to grasp the GeoPandas part. So before going to GeoPandas, I will just introduce you to the Pandas library. So in this, we will learn about basic data structures. What are the basic data structures used in Pandas? So there are two basic data structures in Pandas. One is data frame and another is series. Then we'll learn how do we access and manipulate data within a data frame or within a data series. And next we will see that how do we import. Suppose if you have a CSV data or a CSV file, that we will see that how do we import these data into a data frame. So Pandas is an open source BSD licensed library providing high performance, easy to use data structure and data analysis tools for the Python programming language. So basically Pandas is a column oriented data analysis Python library. It's a great tool for handling and analyzing tabular data. So now we'll start with the basics of Pandas. So anyway, like installing Pandas, similar way either you can install it through Anaconda Navigator or through Conda. Like here I have installed Conda install Pandas. So with Conda install Pandas or Conda install GeoPandas. So that way you can install Pandas either use Navigator or Conda. So once the library is installed, so generally this is the general statement used for importing Pandas. Import Pandas as PD. So this is a standard you can use also. So import Pandas as PD. Now the primary data structure in Pandas are implemented as two classes. So whatever what extensively you will use during in Pandas are the two data structure. One is data frame and another is data series. So data frame you can imagine as a relational data table. So any relational data table that having multiple columns, rows and columns, so that the entire table we call as a data frame. And series, and inside the data frame every column is like a series. So your entire table is data frame and individual column in that individual column in that complete table is a series. So many series make a data frame. When you combine multiple series together using some logic, so that will be a data frame. So data frame will contain multiple one or more data series. So so let us start. Okay, let's see how do we create a. So series is like a column. So series is a column. Column will have multiple values. So any column can have one or more number of values. So for importing Pandas, so anyway, like this standard statement, you have to use import Pandas as PD, or anyway you can change this anything. But this is general. Everybody uses this abstraction. Pandas as PD, and I am just importing OS, and I am changing my working directory to the directory where my data is available. So now let us see that how do we create a series. Series means a column. So a column will have multiple values. So a column. So one way to create a series, we can create a series using a pd.series function. So pd.series creates a series, like it will be a column. So column having multiple values. So for example, we can say that pd.series. Suppose if you want to create 3 entries in that column, we want to create 3 entries in that column. So like 3 names of 3 districts of Uttarakhand. pd.series, if we give Dehradun, Almora and Pithogarh. Now if you see, it shows, so this has created a column with 3 entries. A similar way, now instead of this, now we'll just create now we will create 2 columns. Like suppose if you want to create a table which contains name of the, in first column it contains the name of the city, and second column is like population of that city. So suppose you want to construct a table like this. So what we will do, we will first create 2 series. two series. First series like city names, in that we will store the names of the cities, and the second series, in that we will store the population. So here you can see that we have created a city name and population name, and suppose population in Dehradun is 10,000, Almora 20, Pithoragarh 30. So this way we can create two columns, and using these two series we can create a data frame or table. So first we create two series. Now if you see these things, city names already we have seen. So population, so like population also, now another column. One column is city names, another second column is population. Now with these two columns we will create a data frame. So data frame object can be created by passing a dictionary mapping. So one constructor of a data frame is like we have to pass a dictionary. So dictionary of key value pairs. So like here we are creating a, first we need to call there we have called pd.series, now pd.data frame. Then to the data frame, one of the constructor we can pass it as like a dictionary of like column name and what are the values in that column name, like that will be a series. So here like we are assigning it city name column, first name of first column as city name, and values in that column are this series. So first column, then second column population, the values in the population will be this population series. Now if we see, it creates a data frame. Now here we can see that it created a data frame with two columns. First column name is city name, in that the values Dehradun, Almora and Pithoragarh, and second column with name population, in that the population values. So this way now we have seen that how do we create a series, and then how do we combine series to make a entire table or data frame. Now let us see that how do we, now once this is done, now we will learn how do we read a CSV file using pandas. Suppose in my current working directory I have a file with name stations.csv. So I have a file with name stations.csv. Now we will just learn how do we read this file using pandas. So first thing anyway, I have created a variable with the name of the file name. Then next is we need to call in pandas, there are multiple functions available. So you can read different formats, different files. So pd.readcsv. So if you call pd.readcsv and pass the name of file, so it will return the entire table. So it will read the entire CSV file and return a data frame. So data frame will be tabular structure. So here we can see that stations.csv, if I get df equal to pd.readcsv, so it will return me a data frame. Now if I print, so you can see that it has read the entire CSV file and returned a data frame containing these columns. Now with the help of pandas, you can access these individual column, any other value, or like I explained in you can index, slice, or any other operation you can do in this pandas data frame. Suppose if you now you have read, now suppose if you want to know some statistics, you want to calculate some statistics about this data frame. So data frame has a method or function called describe. So it shows you some statistics about the data frame. Another useful frame is like it has a function called df.head. Suppose your table is quite big, so you just want to see only the initial 10 lines, or suppose if you are interested in last 10 lines or last 10 rows of your record, so that also can be done using data frame.tail function. So let us see with an example. So suppose if you call this data frame.describe function, so df.describe, so it returns you the statistics about your data. So whatever columns, it is returns some statistics information about the columns which has number values. Suppose these two columns has the numbers, in others are text column. So it shows the basic statistics about these two columns. Like it says it has 152 rows. So mean of the latitude is 30. Similarly, mean of the longitude is this. This is the standard deviation, minimum values. This is the 25 percentile is at 29.69, and 50th percentile is 30. So similarly, it returns the basic statistics about the columns which has numerical values. So with df.describe, you can get the summary of the your entire table. Now suppose if you want to inspect only initial 10 lines. So by default, it in df.head inspects 5 lines of your starting 5 lines of your table. Suppose instead of that, if you just want to see 7 lines, so you can call df.head and pass it an argument as number of rows which you want to inspect. So df.head 7 will return you 7. Similar way, other function is df.tail. So df.tail will return you last 5 lines from your table. So df.table or data frame, I will be use them interchangeably. So it returns the last 5 lines. Similarly, suppose if you want to see last 10 lines, then you can pass df.tail 10. So this returns you last 10 lines of your table. Next, suppose if you want to access some particular row or column or some particular value you want to access, like you want to index or slice. So that also can be done using, you can access the data frame data using familiar Python dictionary operation. Like in the dictionary operation, what we were doing, we were just giving index as the key as the index. So like dictionary and pass it the key value. Now suppose if you want to access this particular column, or like just you want to extract the station ID column, so you can just pass df and in square brackets, like you are doing in dictionary, the name of the column. So it just returns this particular column. Similarly, suppose if you want out of this the second row you want to access this entry, so df and the second index you can pass as the number which you want to access. So df station ID 2 returns this value. Similarly, like strings or numpy array, you can slice. Suppose in station ID you want entry numbers 4, 5, 6 and 7. So instead of 2 you can pass 4 colon 8. So starting index and end index. So it returns you entries 4, 5, 6 and 7. Now suppose if you want to, from this df station column, suppose you want to extract the row corresponding where the district name or station name is Haridwar. So you can access it like df station is equal to Haridwar. So this will extract the row where the station is equal to Haridwar. So here it has accessed the row which has station's value as Haridwar. The way you have accessed the data, similar way you can manipulate the data. Suppose if you want to change some values, that also can be done very easily using pandas. So there is a function like, suppose if you want to, now you want to convert this latitude is in degrees. Now suppose this you want to convert every latitude in degrees to minutes. So that suppose if you want, it means that you want to multiply every value in the latitude or longitude column by 60. So that can be done very easily. So just you like df, and suppose if you want to make it as a new column, so you can df square brackets name of the new column equal to whatever formula you want to apply. You want to apply df on the latitude column, df latitude multiply by 60. So it will multiply every value in the df latitude column by 60 and create and assign it to a new column name df lat in min or minutes. So now if you inspect df, here we can see that it has created a new column, and there the value is multiplied 30.70. So it is multiplied by 60. So this way you can apply any operation on any column, or even you can apply operation on multiple columns together and so on. Now, what is the index? So actually both series and data frame objects also define an index property. So index is the, see actually here you have the names of the column. Similar way you have the names of every row. So the name of every row is, we refer it as index of that data frame or series. So both series and data frame objects also define an index property that assigns an identifier value to each series item or data frame row. So when you are talking about index on a series, so series actually is a singular column. So on every singular column, to every value you can attach an identifier, so that instead of remembering indexes, you can access that particular value in the series using that index. Or when you are talking about a row, we talk about a data frame, then every row has an index. Like we have the column names, similarly every row also has a name. So that can be accessed instead of remembering integer indexes, it can be accessed using string index. So in case of a data frame, the index is assigned to every row. So here by default it is assigned 0, 1, 2, 3, 4, 5, 6, 7 numerical indexes. But you can change it and assign it as some string index to a in case of data frame. So in case of data frame, index means the name of row. So every row you are attaching a label, so that we will call index. By default at construction, pandas assign index values that reflect the ordering of source data. So like start from 0 to that number. The index values are stable, so that is they don't change. Suppose if you reorder the data, those indexes doesn't change. So means that in this order only you created the rows. Now suppose if you filter, change or reorder your rows, those indexes by default doesn't change. If you want to change explicitly, you definitely you can change, but by default. So suppose later on sometime what happens, you have rearranged the data. So but what happen, these indexes will remain same. So suppose if you brought this row down, but the index will be 4 only always. So that way you are just remembering the order of creation also very easily. So this way you can. So suppose if you want to access the index, so in suppose df dot station id will return that columns index. If you see, so it returns a range index starts from 0 to 152 and every step 1. So you can see that indexes start from 0 to 1, it goes up to stop at 152 one by one. So 0 to 151. Now suppose if you want to reindex, so there is a function called reindex, so that will reorder the rows. So suppose df dot station id reindex 201. So what will happen with this? This row 0 will change to 2, 1 will change to 0 and 2 will change to 1. Now if you see that initial three values, initially they were 0, 1 and 2. Like 46982 ending with 982 was having initially 4982. Now just we reorder the indexes. So now first row is second row, 0th row and first row. Now we have just reordered the rows using reindexing function. 2, 0 and 1. 2 has come at the top, 0 has come on the second and 1 has come at the third location. 47. This way you can reorder the rows. Just using reindex function and give again the 0th index, which index number, second, 0 and 1. Similar way you can reorder the rows very easily. Now there is a, suppose if you want to sort the values of your column by, suppose if you want to sort your table using values in some particular column, suppose if you want to sort it using latitude. So there is a function called df dot sort values. So data frame dot sort values. Then we need to pass it an argument by equal to according to which column you want to sort. So by equal to latitude if you sort it. So df dot sort latitude. So latitude it will be sorted latitude wise. Now you can see. So here actually data frame is an immutable object. Actually by default it is an immutable object. So if you call a df dot sort values, what will happen? Original df will remain same only. It will return you a new data frame. So if you don't assign it to some other variable or to the same, if you don't assign it to some other variable, these values will get lost because df will remain same only. So sorted data frame, it will return as a new. So you need to store it into a new variable. Otherwise it will just forget these values because df will remain same only. Even if you later on if you print df will be same as it was original. So if you are changing it, then you have to assign it to some other variable. So this was the basic introduction to GeoPandas. Pandas. Now let us see that how do we use these things in GeoPandas. So in this, what we will see, these what we will learn, an introduction to, like there in Pandas, there is a data frame. Similar to the data frame in GeoPandas, there is a frame is called a geodata frame. And there we were calling every column as series. Now here we will call as a geo series. Then next, accessing and manipulating data within a geodata frame and geodata series. That is data frame and geo series. That is quite very, it is same as Pandas. The data inside geodata frame or geo series can be accessed in the similar way that that we accessed using in Pandas data frame or Pandas series. Next we will learn how do we read vector data. So we will read vector data with the help of GeoPandas library. Then we will see that how do we manipulate and do some elementary processing on the vector data. Then we will see that how do we write vector data. We will create some fictitious vector data and we will write it using GeoPandas in some shape file format, GeoJSON or some other format. So this is introduction to the GeoPandas. GeoPandas is an open source project. GeoPandas is an open source project to make working with geospatial data in Python easier. So with the help of GeoPandas, you can very easily create, manipulate, read geospatial data which is in vector format very easily using Python libraries. So GeoPandas extends the data types used by Pandas to allow spatial operations on geometric types. So actually by default, Pandas doesn't support geometries. So GeoPandas extends the capabilities of Pandas by allowing spatial operations. So you can apply on all geometrical operations. So GeoPandas is extension of Pandas with spatial operations on geometric types. So primary data structures in GeoPandas are implemented similar way in two classes, GeoSeries. So GeoSeries is essentially a vector where each entry in the vector is a set of shapes corresponding to one observation. So here GeoSeries is a spatial type of column. So in GeoSeries, every value will be a vector. So that could be a line, point or polygon. So this makes it different from a normal Pandas column. So GeoSeries will contain geometries. So every entry in the GeoSeries will be it will be some geometry. So it will be a vector, it can be a line, it can be a polygon, it can be a point, multi-point or polygon. So every row you can say that GeoSeries is a special column. That column contains geometries. So GeoPandas has basically three classes of geometries: point or multi-point, line or multi-line, similarly polygon or multi-polygon. Then next comes the geodata frame. So geodata frame is a tabular data structure. It is similar to the Pandas data frame that contains a geoseries. So every geodata frame must have a geoseries. Geoseries means a column with geometries. So if there is no column with geometry, then that is like Pandas data frame only. So whenever there is a column that has geometries in it, and that is a part of geodata frame. So geodata frame is a data frame that contains at least one of the geoseries. So the most important property of geodata frame is that it always has one geoseries column. So it must have at least one geoseries column. So this geoseries column is referred as the geometry of the data frame. So that we will call as the geometry of data frame. So now let us see that how do we read and write some spatial vector data using GeoPandas. So anyway, I think you must be familiar with there are actually different, like the raster data was written in different formats, so maybe a TIFF file, IMG file or NV or JPEG 2000, JPEG, TIFF and all. So similar way, vector data also can be written in different formats. So one of the most popular format is ESRI shapefile. So ESRI shapefile is a simple non-topological format. So it doesn't store topology. Non-topological format for storing the geometric location and attributes information of geographic features. So what it means that in ESRI shapefile we can store the geometric location of the feature, plus suppose if you want to store with the location plus some attributes of that feature, So those things also can be stored in a ESRI shapefile. For example, suppose you are storing a point data. So point maybe like point will have its geolocation plus some attribute attached to that point. Like suppose if you are representing cities as points, so city will have city name, or suppose so you want to store the population of that city, or which country it belongs to, which state it belongs. These are the attribute information associated with that feature. So location plus attributes you can store with the in the shapefile. Though the shapefile format defines the geometry and attributes of geographically referenced feature in actually at least 3 or more files with specific file extension. So any shapefile with a shapefile plus it will have some associated some other supporting files. So with the help of these supporting, when these all files are available, then only any other software will be able to read that shapefile properly. So like these at least three out of these, at least three are mandatory. So like .shp file. So SHP file is the main file that stores the feature geometry. So this SHP file is the main file that stores the geometry of the feature. It's latitude, longitude and latitude, or maybe the pair of these latitude and longitudes. Then second file is SHX. This is the index file that stores the indexes for the feature geometry. Then DVF file. So the DVF file that stores the attribute information of the features. So in the DVF file, all attributes are stored. So these three files are mandatory, except these three .sbn, sbx and prj. These are optional files. So prj file stores the coordinate system information, like projection information, plus sbn and sbx, these store spatial indexes of the features. So whenever you get any shape file from any source, you must have at least these three files. So if these three files are not available, you will not be able to read that file either using Python or any other software. So if you get any ESRI shapefile, this shapefile plus these associated files are mandatory. So except a shapefile, there is another format called GeoJSON. So GeoJSON is also one of the popular formats for storing vector data. Actually, GeoJSON is a subset of JSON. So in JSON is JavaScript object notation. So that is most popular for data exchange. So there we store the values as key pair, like Python dictionaries, key and value pairs. So in GeoJSON also we can store any feature. Like suppose here this will be the structure of a GeoJSON file. So it will be inside curly braces. So first like type. So type may be a feature point, line or polygon, or it can be feature collection, multiple features. So suppose you are storing a point. So type is a feature. Then next will be the geometry of that feature. So geometry means what is the type of that feature. So that is the point feature you are storing. Then next is the coordinates of that feature. Then suppose if you want to store some other attributes. So attribute will be stored under key properties. So these are keys like type is feature. Then next key is geometry. So geometry keys has these values, type and coordinate. There are other keys like this is a point and these has these coordinates. Then attributes will be stored with the key properties. Then there again it will be a dictionary like name, comma. Suppose if you have another city, state and so on. So this way we can store, this is the GeoJSON. So GeoJSON also we can store geometrical feature or vector data. Except these, there are other formats like geography markup language or GML, keyhole markup language KML, MongoDB, Microsoft SQL Server, Spatial Database, OGCWF service, etc. So we will be using these things, shapefile and GeoJSON, in our demonstration. So like here, if you see, as I explained here, I have shape files. So here you can see that every shape file has with like almoda.shp. This file has associated files .shp, prj, geojson, dbf, cpg, shx. So these all files are mandatory. Suppose if you are storing it in a shape file format. So now let us see that how do we read a shape file. Now here I will first start with this. I have one shape file here, like I have the boundaries of India First I will show open this file using QGIS software. Then we'll open the same file, open and visualize the same file in Python. So like here, India state boundaries .shp. This file I am opening here. So here you can see that this is the shape file of India. So this is showing the boundaries of all states of the India. So this may not be latest and updated file. Plus now you can see that this is the attribute file. Suppose if you want to open the so it has stored multiple polygons. So this is an attribute table. So that stores attributes or attribute of these features. So like here you can see that this has the attribute table. So it has stored the length of shape length and shape area. Two attributes only have been stored in the shape file, shape length and shape area. So like this can be, there can be other attributes, so like name of the state and so on. So these two attributes, this is the file. Now let us see that how do we open this file in Python using GeoPandas library. So similar way, I am just importing my required packages first. So first thing is I am importing GeoPandas. So pandas we were importing at PD. Similar way, GeoPandas we are importing as GPD. Then NumPy if required, otherwise may not be required. Then pandas, then matplotlib for visualizing, and GeoPandas. From GeoPandas import a geo series, and later on we can import like this. This will be helpful when we are writing the vector data. Now when we are just reading, so this may not be required. So I'm just first import the required packages. Then I'm just defining the name of the vector file variable. Vector file is equal to India underscore state underscore boundary dot shp. So this is my file, India underscore state underscore boundaries dot shp. So I just created a variable. Next is on the GeoPandas. In the GeoPandas library, there is a function called read file. So GPD dot read file. So GPD will have multiple functions. So I will write here GPD dot. So read file, read parameter, read postgis and so on. Read file, and argument I am passing it the name of the file which I want to read. So here you can see that so easily, just with a one line of code we have read the entire contents of a vector data. Now let us visualize the file or see the contents. So if I just print India, so now as I showed in the QGIS, so it was showing two attributes like shape length and shape area, plus it has a column geometry. So this is the geometry of each of these features. So every state is represented as a polygon or multi-polygon. So instead of seeing these all, you want to inspect only initial 10 lines or so on, you can use head or other thing. So now this is a gpd.read file will return a geodata frame, because now this is slightly different from a pandas data frame because it has a column or series as the with geometry. So these are like all numerical columns, but this is a geometry column. So it has geometries in as its rows. So every row represents one polygon or multi-polygon. So here if I see inspect India, we can see the inspect. Now let us see that if you want to know that, so every geodata frame will have an attribute called geometry. And suppose if you want to know what is the name of that geometry column, so just you can call India the geodata frame dot geometry dot name. So it says that the name of the geometry column is geometry, or geometry series is geometry. It can have a different name. Now because these are just 73.45, these may be in integer degrees or any meters. So now there is, with every shape file, like we said in previous lecture, so there will be a coordinate reference system associated with the, or projection system will be associated with these polygons, like these points, what is these represent, whether these represent latitude, longitude, or these are in meters, like whether the file is in UTM projection and so on. So suppose if you want to extract the CRS or projection information associated with the shape file, so that can be done using geodata frame dot CRS. So CRS is like an attribute So if you call geo data frame dot CRS, so it represents the detail of the CRS. So it says that this is the geographic coordinate system EPSG 4326. So axis information, latitude, north, longitude is, so these numbers, these 80 and these are longitude and latitude. So this file is in geographic coordinate system GCS, or is in EPSG 4326. So this way we can get the CRS information of the column or of the your shape file. Now suppose if you want to change the name of any column, so actually here the name of this geometry column was geometry. So instead of this, suppose if you want to rename it, instead of geometry you want to say that border of the state, or state if you want to do, so that can be done easily using this. So here in the geodata frame dot rename, there is a function called rename. So India is my geodata frame, India dot rename columns. So which column you want to rename? Column equal to, now geometry columns name I want to change it to borders. And later on what I am calling set geometry. So as I explained that every geodata frame will have a column that represents the geometry of our data frame. So how do we set the column which has geometries? With calling the function set geometry. Set geometry and the name of the function, because suppose now here we are, if you are renaming geometry to columns, then by default what is the geometry column is stored as the geometry of the data frame. But when you rename, this geometry named column will not no more exist. So now we have to set borders at our geometry. So now if I see it here, now the geometry named column has been changed to borders, and that has been set at the geometry of our data frame. Now if I see India.head, you can see that the geometry column has been named to borders. And now suppose if you call this dot geometry dot name, it will return as border. Initially it was returning as geometry, now it is returning as the name as borders. Now once you have read, now suppose if you want to visualize the polygons or shape file. So there is in geodata frame, there is we need actually internally it uses matplotlib only, but directly on the geodata frame there is a function available that is called plot. So if you just call geodata frame dot plot function, it will draw all the polygon, all the features available in your shape file. It will be printed. So here you can see that. Now suppose if you want to change the size of your figure, and pass it another argument called figure size in width and height in inches. So now here you can see that, see all features. So these every features has been drawn in the screen using, just we need to call the plot function and we can visualize the scene. So we have seen that how do we read a shape file. Just call a read file, pass it the name of the file, and it returns a geodata frame, and geodata frame then we can access its coordinate reference system, or which polygons are available, or attributes of the each feature, and so on, and we can visualize it. Now what has happened here, if you can see that every shape file, as you can see that these are one file plus dot shape file, then associated 3 or 4 supporting files are required. Now it is more convenient, suppose if these all files are combined in a zip file, so it will be easier to handle those files. So similar to so now GeoPandas can read. So you suppose if somebody has given you the file in a zipped format, means all these 4 or 5 files are combined together and written in a zipped file. Suppose if you are opening it QGIS or some other software, what we need to do? You need to unzip the file, unzip the file, and then open the shape file from select the shape file from that and open the file. But in GeoPandas, you need not explicitly unzip a file. So GeoPandas can directly read a shape file that is inside a zipped archive. So let us see that how do we read a shape file that is inside a zipped archive. Suppose like here the same India file I have, India state boundaries or India district boundaries I have stored inside a I have stored it as a zip file so that it is easier to handle. So I need not see all the 4 or 5 files are available or not. So I have just zipped all the files into a single zip archive so that it is easier to handle. So now let us see that how do we read a zipped archive or zipped shape file using GeoPandas. So for that, here I have a file named India District Boundaries. So this contains the boundaries of districts of India. So here you can see that if you unzip it, you will get these all files: node SSP, SSX, QPJ, PRJ, DBF, CPG, and so on. These all are combined in a common archive. So how do we open? So first thing, similar way, I have to prepend with the name to a name of the zip file. This, if you append zip colon double slash, so zip colon double slash. So there I have, in the previous case, if you see, I have just given the name of file India state boundaries .ssp plain. But now suppose if your file is available in a zip format, you need to pass it as zip colon double slash and the name of your zip file. But one thing is, by default what happens, your name of your this zipped archive and inside this whatever shape file is there, it should be same. Like suppose here the name of the file is India district boundary.shp. Now suppose if you change it to some other name like India district, just if you say it India district, so then what happens, the GeoPandas will try to search for India district boundary.shp only inside this. So the name of zipped archive and save file must be same. India district boundary or whatever. So suppose inside this the name is India. Suppose inside this the name of shape file is India underscore district dot boundary dot shp. But if you give the name of archive as India underscore districts only, so then GeoPandas will not be able to read the file properly because it will search for India underscore district dot shp only inside this by default. But there is another way to read that if the names are different. So, but that I will not show. So by default we assume that the name of the shape file also is India underscore district underscore boundary dot shp only. So first we have to define a variable with like name of the file using zip file system colon double slash then India district boundary dot zip. Then remaining thing is same only, gpd dot read file and the name of the file. Now if you inspect the file, now this particular file has more attributes. You can see that district boundary dot shape has like shape length, shape area, ID, ISO, name, ID, name, and these are the attributes like name of the state, Jammu, Kashmir, Himachal, the name type to allows, this may be district name or type district, the name of the district and so on. So every district is stored as a multi-polygon or polygon feature. Now suppose if you want to visualize the file, the same function, plot function we can call with figure size. So now here we can see that in the previous plot there were only state boundaries. Now in this file contains the boundaries of all the districts of India. Plus these are the attributes of those districts. So these are the attributes of that district. Like this is a district name is LOC. It is in Jammu and Kashmir state, India, and these are the coordinates, or this is the boundary of that particular district. Like Lahore and Spiti in Himachal Pradesh, these are the coordinates of that district. And this is the detail is in Himachal Pradesh, this is the name of the district and so on. So this way we can either read a shape file individually or a zipped file also we can read. Suppose if your data is in zipped format, so you need not unzip explicitly. GeoPandas itself will unzip and read the file. So directly we can read the file. Later on I am just closing. Now suppose similar way, now you suppose if you want to subset your data frame. Now suppose this is having the districts of entire India. Now suppose if we want to, from this just we want to retain the districts which has state Karnataka. Suppose now we want to subset this data frame and we just want to filter or extract the districts of Karnataka state only. So that can be done like I explained. Suppose I will call a variable as subset, then my our original geo data frame. Actually, in the attribute name one, so name one contains the name of state. So we will filter all the rows where name one attribute is Karnataka. So with that, what will happen? Only the only the features which has a name and name one as Karnataka will be filtered out. So that how do we do that? Here I can just write subset equal to India, and inside square brackets I will write India wherever name one is equal to Karnataka. So this will just fetch or filter the records where the name one attribute is Karnataka. So if I see it subset, now if I see just inspect the head of subset, so here these say all names where just the name is Karnataka only, those values only got filtered out. Now similar way, now subset, suppose if you want to visualize, so now here you can see that this is the these are the districts of Karnataka, and these all districts make the Karnataka state. So that this way we can filter or subset our geodata frame just with a single statement. Now suppose your shape file was quite big, and instead and your RAM or your processing capabilities were limited. So suppose instead of reading entire contents of your, like in raster data frame I showed, so you are interested just in some particular instead of reading and then subsetting, you are just interested just I want to read just this particular subset of my data only. So I don't want to read the entire contents. So that while reading itself, you can apply a geometrical filter to your data. So that GeoPandas, instead of reading the entire contents, it will read just data inside that bounds. So for that, there is a suppose we want to apply a geometric filter. Like I want to read the districts in this particular region only. I have some specified area of interest, and I just want to read the polygons or whatever attribute information available on that. I just instead of reading the entire shapefile, I just want to read that subsetted data. So for that, first I need to define my area of interest. So my area of interest, I am calling it as a variable b box or bounding box. So that is a tuple. So in the tuple, first what I need to define my minimum x, where minimum x, minimum y, max x, and max y. So I want to read from 70 in longitude 77.57 to 81.04, 70.57 to 81.04, and in latitude 28.72 to 31.5. So this way I can define my area of interest or bounding box. So actually this bounding box correspond to some areas of Uttarakhand. So that when I call the read file function, so gpd.read file, and I can pass it a second argument, that is b box or bounding box. In the bounding box, I can specify my parameters. I just want to read this region. So what is the sequence, like in affine transformation? Similar way here, minimum x, minimum y, max x, and max y. Now if I read this UK, now suppose if I inspect read, so actually same thing, gpd.read file vector file. I have done here also vector file only, gpd.read vector file, but I have passed here another argument, that is that bounding box. So I just want to do it a subset. So if I call UK now you can see that some part of Haryana, Himachal Pradesh, with some part of Uttar Pradesh, and mostly in Uttaranchal region has come. Now let us visualize the subsetted region which I have read. I've just called the plot function. So if I see that, so same file I have read, but now you can see that this much area only has been read. So this way I can read the partial, or I can apply a geometric. So instead of reading the entire contents then filtering, I have just read the area which is of interest to me only. So that way I can read the subset of data. Now instead of this, suppose now if you want to read a GeoJSON file. Now here if I have a GeoJSON file. So instead of save file, now suppose your vector data is available in GeoJSON file. So that also can be done. So this is a GeoJSON file. So as you can see, as I explained, that this is a GeoJSON file. So type is feature collection, then CRS is properties name, this is the name CRSC, this, then these are the features and so on. Now let us read this GeoJSON file using GeoPandas and visualize it. So first thing I am anyway like I am creating an ordinary variable that contains the name of my file which I am going to read, tehsil-almora.geojson. Then same function I will call gpd.readFile, and I will pass the name of the file. So by default, it will recognize the extension of file. So depending on the name of extension, it will load the proper driver. Like if the name of the file is GeoJSON, so the GeoJSON driver of the GeoPandas will read and parse the file. So almora equal to gpd.read file, the name of GeoJSON file. So once this is done, now suppose let's inspect. So reading either GeoJSON or shape file is similar. This we need to call the read file function. Let's call almora.head. Now if I visualize it, so this has returned the description of the file. Now suppose if you want to plot it or means visualize that how is the features in your file, GeoJSON file. Here now you can see that this is the file. Now suppose in these things, if you want to print some attribute information of each of these features, like suppose this Almora district, these are different tehsils of Almora district. Now suppose in the map you want to print their name or some any other attribute. So for that we have to call a text annotate function that is part of matplotlib. So we are just creating a access object as explained in matplotlib lecture. So almora.plot, then we are annotating each polygon with the name at the centroid name of the tehsil, x.tehsil name. Now here you can see that this way we can annotate each polygon with some attribute. Like here we have taken the name of name attribute. You can take, and here actually we have taken this tehsil attribute. The similar like district will be the same. So if there is any other attribute like population or another attribute and you want to annotate each polygon with that attribute, that also can be done so easily. So this way you can create nice maps. Now this is reading. Now let us see that how do we write a shapefile. So initially we will create some basic shapefile, and later on we will see that how do we create some other features. Now here what I am doing, already we have a geodata frame with name Almora. So now suppose if you want to, we will just attach one more column here that we'll call as population. So we will generate randomly some numbers in range, we will generate some random numbers or some increasing numbers in increasing order. Then we'll call it as a population. So here we are creating a new series, like a new column, as I explained in pandas. Population, we are creating a new series, population pd.series. So np.line space function, we are calling np.line space function, which generates, so actually it has 8 rows, so 5,000 to 20,000, and 8 entries it will generate. So we are generating some random population or some increasing population. So now if you see the population will be a column. So it has like 8 rows. So it has 8 rows and every row has these values. Now we will attach this particular column to our Almora geodata frame. So we will say that Almora population equal to this population. Now if we see almora.tail, now a new column with population, with the name population got added to this, and this is. Now how do we write this file? So like there we were using GeoPandas dot read file. Now here already we have a geodata frame. It has a nice geometry column also. So geodata frame dot to file, geodata frame dot to file function, and we have to pass the name of the file. So by default, actually the format, it will be Suppose almoda.shp. So here you need not to pass another argument like called format, in which format you want to save. So by default, the format will be ESRI shapefile. So whenever, if you suppose if you want to write your data, so if there is any other file with almoda.shp, I will delete that file. So just almoda.to file and almoda.shp. So now it must have written a file almoda.shp and its associated file. Now if I see here, so it has created the file almoda dot, this is the shape file, and these are the so what do you call supporting files of this. Now suppose if you want to open this file in QGIS or any other software, that is just you want to inspect. Now almoda.shp. So here you can see that the same file is generated and plus attribute. It has attribute table also. One attribute. Then we attached a new, and with tehsil district, these were there. Then we attached a new column attribute called population, and that can be visualized here. So next, now suppose instead of shape file, you wanted to write a GeoJSON file. So you don't want to have so many files. Just you want to write a GeoJSON. So there is no GeoJSON file right now in the available. So now next, the same function we will call in geodata frame.to_file. Then the name of the file, instead of almoda.shp, we will call almoda.geojson. Then here explicitly we need to define a driver. So almoda.to_file, almoda.geojson, and driver equal to geojson. So by default, driver will be equal to ESRI shapefile. But now suppose if you want to save it as a GeoJSON file, you need to specify driver is equal to GeoJSON. Now just if you write almoda.to_file GeoJSON, so there will be a file with name almoda.geojson. Here it got created. If you inspect the content, now here you can see that this is the GeoJSON file. So just with a single statement you can create different formats. So like there are other supporting formats that you can read about these formats in GeoPandas. You can just go to GeoPandas website, and you can just read about which other formats it supports and how to read and write other formats. Other formats are also same only just it will be, the difference will be the name of your file and the which driver or format to be used for writing. Now once we have done, now just let us see that how do we create maps with GeoPandas. Now here I will read the same file tehsil dot shape file, and we will visualize it in different formats. So I am anyway first creating the file. So GeoPandas anyway provides a high level interface to the matplotlib. Actually internally it calls matplotlib only, but we need not explicitly call the functions of matplotlib. So pandas internally will call matplotlib function, but it gives you a high level interface, just data frame.plot, and you can pass different arguments to the plot function. Internally those will be converted to the matplotlib system calls, but you need not worry about that. So those all things will be handled by GeoPandas. Okay, let us see that. We'll just read the Uttarakhand shape, this tehsil.shape file. This contains the tehsils of Uttarakhand. Let us read the file and let us inspect. So there you can see that this is just head. So this is the district of Uttarakhand. These are the tehsils of Uttarkasi district. Now suppose if you now let us, by default it was giving a blue color. Now suppose in the map here, if you see the plot, it was in blue color. Now suppose instead of blue you don't like the blue color, you want to change the color. So you can pass an argument to the plot function, that is color. So if you pass color equal to color of your interest, so suppose here I am passing the color equal to green, So the color of the face of every polygon changes to green color. Similarly, now suppose I attach a population column to my data frame, like I am generating some random numbers and calling them as a population of Uttarakhand. And now next I am creating a new column with name population, and that population I am assigning the value population series. So this we have created. Now suppose if in this we want to make choroplast map, like suppose if you want to color the different tehsils or districts according to their population. So GeoPandas makes it quite easy to make choroplast maps where the color of each shape is based on the value of some associated variable. Now suppose if you want to give the color to each polygon based on the population or a population attribute of that polygon. So that is called a choroplast map. So that is also quite simpler to be done. So just you can call Uttarakhand.plot and which column, which on based on which values of which column you want to color your polygons. So that is like Uttarakhand.plot, then column is equal to, just suppose on the base, we just want to give the colors based on the population. So color equal to population if we give. So here you can see that all the polygons have been colored based on their population. But right now we don't know that which color represents what population value. So when the map will be readable only when there will be a legend attached to the map, because if you see just this map you will not be able to, you don't know which color represents which value. So for that we need to attach a legend to our map. So suppose if you want to attach a legend to our map, what we need to do? We need to call the same function Uttarakhand.plot, like GeoPandas, GeoDataFrame.plot, name of the column on which you want to color, and legend equal to true. If you pass legend is equal to true, it will attach a legend to your map. So now here you can see that a legend got attached to your map. So like this color represents population in this range. So 20 to 30,000 this range, 30,000 to 40,000 by this color. This is the color variation. This way you can attach a legend to your map. Then suppose if you want to change the orientation of your legend, like instead of vertical column, you want it to be a horizontal legend. So legend you want to make it horizontal. So that also can be done like using, there is another argument to your plot function, that is legend keywords. So suppose you want to decorate this particular legend. So there is another argument that is called legend keywords. So legend keywords will be a dictionary of key values pairs. Like these are the key values, maybe there, like a label. What label you want to give? Like here there is no label attached to this. So what is this 80,000? We don't know. So 80,000 whether it is a population or any other thing. For map reader, those all information should be available so that only the map will be readable. So here we are attaching a label to our legend. So label population by tehsil. Then orientation. Another key is orientation. Orientation you want it to be horizontal. And next is figure size. If you call this, so it will create a horizontal line, and then this population by tehsil. So we have attached a label to our legend. So this way very easily you can create, like suppose if you want to create this map on another attribute, so that also, like you can call column equal to, and then you can, according to your choice or size of figure, you can attach horizontal or vertical legend and attach the label to that legend. Now similar way, suppose these are the colors. Now suppose instead of this default color scheme you want to change this color map, you want to create by your own. So actually there are different color maps available. So if you don't like this default color map, like in raster data, you also can change here also color map. So then you need to pass another argument as CMap. So CMap, there are different color maps available. So you can use any different color map like accent, or actually in the documentation you can see there are multiple even color maps which are applicable to matplotlib also are applicable here. So that in that way you can change the color map. Now suppose the way color maps are scaled, now by it will, these color maps will be scaled by default using some algorithm. Now suppose you want these, how these color maps are scaled, there scaling value, scaling algorithm also, scaling option or scaling scheme also, suppose if you want to edit. So that also can be done. Like suppose the option for breaking the ranges of these population or these attribute values. So there are actually multiple schemes. Suppose you want to classify these values or using different algorithm. So there is a called map classify. You need to install map classify, and there are actually like suppose if you want to break the ranges using box plot equal, you want to your population range you want to break into equal intervals, or you want to break into like maximum breaks or natural breaks. Different schemes are there for breaking the entire range of our attribute to subsets. So there are multiple values. So now suppose if you want to change your scheme to natural breaks, or you, instead of that you want to break it into, suppose if you want to break into equal intervals, like suppose you have values from 0 to 10,000 and you want to break into 10 values like 0 to 1,000 one color, 1,000 to 2,000 another color, 2,000 3,000 another color. So that is called equal interval. So like this way there are multiple schemes to break that data into sub ranges. So these are the options. So that option also you can specify. So like Uttarakhand dot plot, then you can, anyway column is same, then color map, which color maps you want to assign, and legend anyway, and scheme, like which scheme you want to use for breaking your data into multiple ranges. So like here I am passing natural breaks. Now if you just see, this is just classifying the values, and now here you can see that the numbers got changed. Now here, see here, you can see the just it has broken into equal intervals 20,000, 30, 40, 50. Now the entire range has been broken here using different ranges like 1,000, 100,832, 2365 in one color, and this. So here you can see that these numbers have changed. Instead of natural breaks, you want maximum breaks. Then you can pass it as maximum breaks. So this way you can break your data into different ranges using different classification functions. So this is all for today. So today I introduced you the basics of pandas, then we continued with data frame and series, then same GeoPandas we extended to geo data frame. So geo data frame was a special column that is having a geometry column. So that was the GeoPanda. Geo data frame was the GeoPandas is the extension of pandas library. Then we saw how do we read and write vector files, how do we subset. Also, if you are interested in reading only subset of the file, then later on we learned how do we make maps from our vector data and using different color schemes and so on. So that's all for today. Thank you very much.